Hey everyone, Tim Taylor here again. In a previous video, I reported on the growth in utility-scale solar as described in a Berkeley lab report released around the end of October. Berkeley Lab is a great resource on utility-scale solar, and since it's a U.S. government lab, all their reports and data are publicly available. Go to their website if you want to get more details about the summary of points in this video. So let's look at the installed CapEx costs for utility-scale solar. And this graph shows the cost has declined over the last 13 years. So this graph is showing the different projects for which data has been made available. And the size of the circles is representative of the capacity of the projects. The solid line is the capacity-weighted mean. Now, keep in mind that Berkeley Lab gets their data from a number of sources, including FERC Form 1, state regulatory filings, and EIA 860, which is actually confidential, but Berkeley obtains the data with a non-disclosure agreement. So these are capacity-weighted costs, representing the average cost of the capacity, and it's only for projects greater than 5 megawatts. So some key points. Costs from 2022 to 2023 dropped from $1.56 per watt AC to $1.43 per watt AC, and that is an 8% decrease. So the data that Berkeley Lab has compiled with respect to 2022 and 2023 is different than other industry sources, which have actually reported some cost increases in real dollar terms. For those of you that think in terms of DC watts, $1.43 per watt AC is equivalent to $1.08 per watt DC, and that's according to how Berkeley Lab calculates that. Since 2010, costs for installed utility-scale solar have fallen by 75%, and that's a key reason why we are seeing that the dominant source of new generation on the system is solar PV. Now, another key point that I found very relevant in the Berkeley Lab report was the comparison of fixed tilt versus tracking CapEx cost. And as you can see by these two curves here, that there is roughly the same order of magnitude reduction for both fixed tilt and tracking. And as Berkeley Lab found, 96% of all new capacity uses trackers. Fixed tilt runs about $1.20 per watt AC, while tracking is running about $1.40 per watt AC, and that's about 17% greater than fixed tilt. And of course, the increased production from tracking projects justifies the higher capital cost and potentially higher O&M cost associated with tracking. And other data compiled by Berkeley Lab shows that tracking increases capacity factors approximately 5% in high solar insolation regions. That's it for this video. I'll be talking about a few other key aspects of this report in future videos. To learn more about transmission interconnections, scan the QR code here or head over to heatspring.com. Thank you for watching.